Hi, we're going to look at Medical Interventions Lesson 3.2.3, and this is an instructional video on how to do the marker analysis. So we have tested Judy Smith and several of her family members for the presence of one of the markers for breast cancer, BRCA. And so now we've got this gel with fragments from their DNA, and we're going to measure how far they move through the gel. This is going to help us to determine how many base pairs long each of these fragments are, and we're going to use the base pair length to determine what alleles are present for these individuals. Okay, so if we look at the actual lesson, we're going to be filling in this chart here on step 16. However, you might have a Google Doc that has the same table just in a Google Doc format instead of this. Okay, the actual gel it's part of the lesson. You can see here it tells you about our F value. Our F value is going to help us, we're going to use that with a graph to help us determine the actual length of our fragments. Okay, so let me show you how to do this. All right, so we're going to start with Diana. And here's Diana's well that her DNA started in. And so when we turned on the power on our electrophoresis equipment, the fragments started moving through the gel down towards this green line. The green line is going to be our reference point. So the first thing we want to know, if you look at the table, is the distance that the fragments migrated. So Diana's fragments, fragment 1, and so the first value, A, is going to be the distance that it migrated from her well. All right, so I'm going to take this ruler, and if you look at the 0 line, the orange line that ends in 0 there, I want that line to line up with the bottom of the white box that says Diana's DNA. All right, so now I've got that lined up, and I'm going to look at this first fragment of Diana's, the top fragment here. To find out how far it moved, it started in the white box. I'm going to follow down the ruler. Okay, so the ruler is marked out in centimeters. So here's 1 centimeter. Let me move this. Here's 1 centimeter, here's 2 centimeters, and there's 3. So the fragment moved almost 3 centimeters. If we look at, we're going to look at the bottom of the fragment and measure that, and we can see that it's on this last line right before the 3. All right, so that's 29 millimeters, okay, 1 centimeter, 2 centimeters, and there's 10 centimeters in 10 millimeters in a centimeter. So that's 20 millimeters, and then plus the 9 of these little tiny millimeters here. So I'm going to go back here, and fragment 1 migrated 29 millimeters. Okay, now the second thing I want to know is the distance from the well where the DNA started down to the reference point, that green line. All right, so yeah, here. So I'm going to leave the ruler where it is. It's already lined up. The 0 mark is already lined up with the bottom of Diana's well. And again, that's where the DNA started. And then when we turned on the power, all the fragments started moving through the gel towards the green line. The green line's our reference point. All right, so we can see that this is 1 centimeter, 2, 3, 4, 5, 6 centimeters, and 7's all the way down here. So the reference line is what I want to look at. I want the bottom of the green line to be my reference point. So that would be 6.5 centimeters, 6.6, so almost 6, I'm going to call it 6.6 times 10 would be 66 millimeters. So I'm going to go ahead and put 66 millimeters for the distance to the reference point. All right, and then to find the RF, you take the distance migrated divided by the reference point. Ooh, I don't have a calculator with me. Let me pull this one up real quick. Okay, so let's see, we got 29. We're going to divide it by 66. And let's see, what happened here? It's 0.44, okay, 0.44, I'm just rounding up here. Okay, so I'm going to put that there, 0.44. That's the RF value. And the RF value, you're going to use the graph of the marker DNA called the standard curve, and you're going to use that 0.44 to determine the base pair length of fragment 1 for Diana. All right, so go ahead and do the rest of it on your own. Have a great one.